Namaste everyone. In this video we'll be doing a problem on velocity analysis on a four-link mechanism, and the question that we'll be solving is given here. So you can see all the dimensions of the four links have been given. One of the angles has been given, and velocity of one of the links has been given. And we are supposed to find the velocity at various other points. Like first we have to find velocity of point C, and we have to find velocity of another point E, which is located on link BC, and the length BE is given. And we have angular velocity of BC and CD to be found. We have the velocity of point F, which is offset from the link BC, where the BF length, CF length has been given, and also the direction in which BCF are going to be read. They are going to be read clockwise. Similarly, we have another point G on CD in similar way to what we have been given above, and we have to find also the rubbing velocities of the points A, B, C, and T, wherein at all the points the pin diameters have been given. So you must have seen here that by solving this single problem, we get an idea about all kinds of velocity analysis that we may be required to do. So in order to solve this particular problem, we'll have to first draw the position diagram of the four-bar linkage, four-bar mechanism. So let me go ahead and draw that. So you can see I have created a few blocks which will be helpful for us now in taking all these measurements. So let me put the scale over here, and let me take the first link length. So first link length we have to take is AD, and that length has been given as 100 mm. So let me take a length of 100 mm over here. So this is our first link AD. Next we'll have to create the length AB, and we have been given the angle DAB as 60 degrees. So let me take a protractor over here, and I'll have to draw an angle of 60 degrees. So I'll have to take it from this side. Okay, so let me draw this as 60 degrees over here. Fine. And the length that we need over here is exactly 50 mm. So you can take a scale over here. Take a scale over here. Okay, I'll use this, make the scale, and I'll have to rotate it here, and I'll have to take measurement of this as 5. Fine. So this point over here is our point B, capital B, of course. So now that we have taken this angle is 60 degrees and the length is 50 mm, we'll have to find the other two lengths, that is BC and CD. So BC length you can see has been given to us, and I'll be using okay, I can just go ahead and use this privilege. Right. So let's go ahead, use this measurement, and the length that we want here on this is BC length. BC is 66. Take 66. So this way you have to take your compass. You have to take your compass. At the compass you have to take that measurement, and of course you need to mark an arc also through this. So next you'll have to take compass again, and from this point as center you'll have to mark the other length, that is CD, which is given as 50 K. So once again I'll be using this thing, center one, and this time I need the length 56. So 56. Okay, and of course you need to draw an arc passing through this. Of course we will not be using the complete circles, we'll just be using parts of this. So let me use this out of here to remote house, and only these two arcs will need, and by joining these with our point we get the final mechanism. Fine. So this is the complete position diagram. This is the complete position diagram. So we have A, B, C, D according to the given dimensions. Now this diagram will be using in order to complete our velocity diagram. So let us draw the velocity diagram over here. For this we'll have to first do some calculations. Okay, so in order to start building the velocity diagram, we'll have to first calculate one of the velocities. Now we know the angular velocity of link AB, and so we can easily find the velocity of B. So let's go ahead and do that. So velocity of B with respect to A. A is of course fixed point, so this velocity becomes the absolute velocity. So now this is given by omega of BA, and it needs to be multiplied with the radial distance, and that is BA itself. So we can read the problem to see that omega has been given as 10.5 radians per second, and the length BA or AB has been given as 50 mm. So this mm needs to be converted into meters, so we need to divide it by 1000 to get meters. So when you do the calculation, we get 0.525, and this value is in meters per second. So we need to choose some scale for us to actually draw these velocity diagrams, velocity in the diagrams, and we'll have to choose it conveniently. So let us go ahead and multiply 10 to this to take it in centimeters. So we were taking it first for velocity of B with respect to A, and the actual velocity is 0.525 in meters per second, and for drawing length we are going to take it as 52.5 mm. So you can see that the scale I'm using here from left to right is multiplying by 1000, and so whenever you get the values from the diagram, you just need to divide it by 100 to get back the value in meters per second. Okay, at this point we can go ahead and start making the velocity diagrams. You can see we have calculated the velocity. We'll be drawing 52.5, and its direction needs to be perpendicular to the length AB. So let us take our drafter, keep it parallel to AB, and we need to take the other edge, and the other edge means this edge, and we need to draw that length. So we have to draw 5.25, so we have to take a midpoint between 5.2 and 5.3. So this is our first velocity diagram, and because it is rotating anti-clockwise, the velocity will be in upward direction. This point represents 2 points from the position diagram, A as well as D, and this point over here is the point B. So this velocity will be called as VBA, that is velocity of B with respect to A. And because the point A is fixed point, this becomes the absolute velocity of the point B. Now you can see here that in the first bit we have been asked to find the velocity of the point C. In order to do that, we'll have to draw two more lines, the velocity of C with respect to B and the velocity of C with respect to the fixed point D. So once again, I'll have to take the drafter, make this parallel to this particular line, and then I'll have to use the perpendicular line here, and I need to draw a line perpendicular to this link passing through point B. Then I'll have to place my drafter parallel to this link length, that is CD, and then I'll have to draw a line perpendicular to the link CD, which is passing through this other point. Fine. So now that we have drawn the line perpendicular to BC and perpendicular to CD, we will get an intersection point of these two, and this intersection point is our third point, that is C. Of course, that is the small c, and we will be able to thus get the velocity of C with respect to D and the velocity of B with respect to C. So now when we are talking about this as velocity of B with respect to C, the arrow mark is going to be appearing in this direction, and if you want the velocity to be other way around, that is velocity of C with respect to B, the direction of this will be reversed. Okay, so this is the velocity diagram, and by measuring the edges of this, we'll be able to get the values of these velocities. So let us go ahead and find the velocity of c. So when he asks the velocity of c, we need not measure it with respect to another moving point. So these two are not the velocities we need. We need absolute velocity of c, which is with respect to a fixed point. So velocity of c with respect to d is what we need to find. So let's again go ahead and measure it. You can just take a normal scale and we need to measure it. So we need to place the scale parallel to this, and let us see what is the length. We are getting almost exactly 4 centimeters. 4 centimeters. So this 4 centimeters we have to take here. So this we are finding velocity of c with respect to d. We are getting the value from diagram, that is 40 mm, and this we need to convert it back to its value in meters per second. So we'll be using this scale here. So we just need to divide it by 100, and that gives us 0.4 meters per second. So that's the answer to our A bit, 0.4 meters per second. Let's go ahead and see what are the other bits. So second bit is we have to find the velocity of point E, which is located on link BC, such that BE length is 40 mm. So I'll have to again take my length over here. I have to take compass, and with compass I'll have to take that length, that is 40 mm. Let's take 40 mm, and this passing through this 40 mm, I'll have to draw an arc, and this point that we're getting here is the length we want, is the point we want. So this point here is point E, capital E. So now we need to find the velocity of this point E. Fine. So in order to do this, we'll have to do some calculations. I have taken a copy of that over here, and we need to find this point B, E on BC. Fine. So again, the small E point will again be appearing on BC length, but where it will appear exactly, we need to find it. So we know that the length BE is 40 mm and the length BC is 60 mm. So we need to use the same calculations which we used as a kid. I just prefer to call it as mango method. So BC and small bc. So BC, capital BC length is 66, and small bc length we actually need to measure it. So let's see what that measure comes out to be. Okay, so I'll just take this one. Okay, let's just need to rotate it. Okay, and we get that length as 3.4, almost 3.4 exactly. So 34 mm. So BC, small length, we are getting 34 in mm. So now we need to find the length BE using the capital BE. So this length we know it as 40 mm, and small BE we need to find. So as a kids, we just used cross multiplication and divide by this as a simple rule. So 40 times 34 divided by 66 will give us the value. So you can see that is coming out as 20.5. So 20.5 mm. So let's take this as 20.5 mm, and that needs to be taken from this point E, such that this length is 20.5. Let me go ahead and do that. So I need to come back here, take my scale, and on this length BC, I need to take a length of 20.5. So let me take a point, 20.5. So 20 is here, 20.5 is going to be in between these 2 points. So this is my point. So now you can see that we have marked the point E. So this point here, what we got is E, small e of course. And when we want to find the velocity of E, we have to actually find the absolute velocity of E, and that needs to be joined with the fixed points A and T. So this length actually gives us the absolute velocity of the point E. Let's measure it to see what's its length actually. Okay, so I just need to orient this properly, and we can see that its length is coming out to be 4.2 centimeters. So 42 somewhat centimeters. So this 42 centimeters, again we'll have to convert it using the same scale that we had used for the velocity diagram. So we got 42 mm over here. So when we convert it back, we just need to divide this by 1000 and we are getting 0.42 meters per second. So this is the answer to our B bit. So that's it for this video. In the next video we'll take up finding velocity of points which are displaced from the linkages, and of course rubbing velocity will be covered in another of the video. So goodbye for now.